4 introduces some super important vocabulary. So my hope is that you guys have the note page, and I'm going to pause and open that real quick just to show you what I'm talking about. The sheet I'm talking about. So hopefully you guys are following along and jotting down some notes as we go. But intersections, unions, and complements are 3 vocabulary words we're going to have down. It'd be nice to have the addition rule down too. It's just kind of a shortcut, but the idea is you definitely need to know what an intersection is versus a union. The complement, again, is just kind of a shortcut, but understanding the difference between an intersection and a union is going to be crucial. All right, so in this chapter, you have used a variety of models to represent the elements of a sample space and to calculate probabilities. Today, you will continue to focus on the probabilities of independent events, and you will learn new ways to describe particular subsets of the sample space. So election day is less than a month away, and political analysts are focused on the races for 2 statewide political offices. According to a recent poll, in the race for governor, 40% of the voters support the Republican candidate, 53% support the Democratic candidate. In the race for the Attorney General, 61% support the Republican candidate, and 37% of voters support the Democrat. Assume that voter preferences of candidates for each of the 2 offices is independent. That means, and in real life, I would say they're probably not independent. I would say they're probably very dependent. People are very much more likely, if they're going to vote for the Republican governor, they're probably going to vote for the Republican Attorney General as well, and vice versa. If they're going to vote for Democratic governor, they're probably going to vote for the Democratic Attorney General. But this problem is saying the opposite. They're saying you're just as likely to support the Republican or Democrat for governor as you are the Republican or Democrat for Attorney General. So you might like the Republican governor, but you might like the Democratic Attorney General. And again, I'm not sure how realistic that is in real life, but that's what they're telling us right now. And that really, when you dive into statistics, those are the kinds of things that you're really looking for, those relationships. Are you more likely to vote all Republican or all Democrat, or how many people vote one or the other? Or, there's a lot to it. So we're keeping it very simple. But anyway, moving on. So it says, what's the probability that a randomly selected voter supports both the Democratic candidate for governor and the Democratic candidate for Attorney General? Well, I would say that, you have to multiply the 53%, right? The 53% of people who want the Democratic governor, and I would multiply that by the 37% of people that want the Democratic Attorney General. And again, I'm going to say 0.53 times 0.37, and then I'll convert it back over. But it looks like 19.61%. 19.61% of people prefer both Democrats. It says, what's the sample space for all possible outcomes in voter support of the candidates for governor? Well, I'm going to make and Attorney General. I'm going to make the first one the governor and the second one the Attorney General. So you might go Democrat, Democrat. You might go Democrat, Republican. Or, don't forget, you might go Democrat, other, right? This only adds up to 93% of people that want the Democratic governor. So if you like the Democratic governor, and there's only 98% of the people that like the Republican and Democratic Attorney General. So there's an other there that's not being counted. 7% of people like someone else besides a Democrat and Republican, and 2% of people for Attorney General like someone else. So don't forget about that. So that's Democrat, 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 Republican, Democrat, other. But you could also go Republican, Democrat, Republican, 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 other, right? You might like the Republican governor and the Democratic Attorney General, or the Republican governor and the Republican Attorney General, or the Republican governor and the other Attorney General. And then finally, don't forget, you might like the other governor and the Democratic Attorney General. You might like the other governor and the Republican Attorney General, or you might like both others. So there's 9 possibilities for you to vote in your sample space. And again, I hope this makes sense, because a lot of times people miss that. So it says a set of outcomes, a subset of the sample space, is called the event. So which outcomes from the sample space are in the event supporting Democratic governor? Which outcomes are in the event supporting Democratic Attorney General? So I might have missed something, but I don't think they have yet asked me to come up with a area model, and I'm going to do that now. I'm going to make an area model with the percentages so that I can answer some of these questions here. And I think what I'm going to do is I'm going to put the area model right on top of this data. So we're going to lose this data, but it will just be replicated in the area model, so we're not really going to lose it. Where we're at, I've turned this into an area model. There's a lot going on with this. So one thing I do want to talk about is how I got these numbers in the middle. So again, let's just focus on this 0.14. How did I get this 0.14%? Well, I know that the other governor was 7%, and I know that the other attorney general was 2%. So I went over here and I said, all right, so 7% is 0.07 times 2% is 0.02. And I got 0.0014. Well, if I move the decimal 2 places, it comes up to 0.14%. So 0.14%. So you can see I did that for all of these, and that's how I got all these percentages, just so we're on the same page. And again, if you're in this box right here, that means you support the other governor, and it means you support the other attorney general. If you're in this box, it means you support the Republican governor, but you support the Democrat attorney general. So hopefully we're okay with like reading this table and how all this works. So it says a set of outcomes, a subset of the sample space is called an event. So which outcomes from the sample space are in the event supporting the Democratic governor? Well, think about it. If I support the Democratic governor, I'll use blue because that's the color of the Democrats. These people support the Democratic governor. They just like the Republican attorney general. These people support the Democratic governor, but they support the Democratic attorney general. And these people support the Democratic governor, but they support the other attorney general. But these three groups are all the people that support the governor. And again, they're not all the same. Some like the Republican for the attorney general, some like the Democrat for the attorney general, and some like the other for the attorney general. So it says a set of outcomes, a subset of the sample space. You can see it's a subset. We're not talking about the whole sample space, just a small part of it. Which outcomes from the sample space are in the event supporting the Democratic governor? Which outcomes are in the event supporting the Democratic attorney general? So that answers the question for the Democratic governor. So for the Democratic governor, we'll say it's DR, DD, and DO, right? So hopefully we're on the same page there. So for the Democratic governor, we'll say it was DR, DD, and DO, because don't forget we're putting the governor first. Well, how about if you like the Democratic attorney general? Well, if you like the Democratic attorney general, these people like the Democratic attorney general. The people that like the Republican and the Democrat, the people that like the Democrat and the Democrat, and the people that like the other and the Democrat. So you can see it goes side to side. So again, if we want to type that up, we would say it is RD. There we go. So the people who like the Republican governor and the Democratic attorney general, the people who like the Democratic governor and the Democratic attorney general, and the people who like the other governor and the Democratic attorney general. You can see this one, the D's are all the governor because they come first. This one, the D's are all the attorney general because they come second. But these are known as our subset of the sample space. All right, so it says the intersection of two events, A and B, is the event consisting of all outcomes that are in both A and B. So if you have not already done so, create an area model for this situation. What outcomes are in the intersection of the events Democratic governor and Democratic attorney general? How can this be seen in your area model? So again, we're going to go through and we're going to say, all right, these people like the Democratic governor, and I'll just give the slash in one direction. These people like the Democratic governor. These people like the Democratic attorney general. Right? And what we want is the intersection of A and B. The intersection is the event consisting of all possible outcomes that are in that are in both A and B. So if you do not have already done so, create an area model for this situation. What outcomes are in the intersection of the events Democratic governor and Democratic attorney general? They have to like the Democratic governor and they have to like the Democratic attorney general. So we would say right here, this 19.61. So let me go ahead here, and we would say the ones that are in both is DD. They have to like the Democratic governor and the Democratic attorney general. And we would say that is 19.61% of the people. And again, what's really important here is that we understand that an intersection is an and question. They have to be in this column and in this row. These people are not both. They are only in the row, but they're not in the column. These people are in the column, but they're not in the row. These are the only people that are in both, and that is known as an intersection. It's an and question. They have to do the Democratic governor and the Democratic attorney general. It says shade your area model to highlight the event Democratic governor, then shade your area model to highlight the shade Democratic attorney general. What do you notice about the intersection? The intersection are both. Excuse me for a second. Again, I didn't shade these, but I did give them X's in both directions. And again, if it's an intersection or an and question, you need the left slash and the right slash, or you need this shading and this shading. So just make sure we're on the same page with that and. All right, so it says Darren is a Democrat and is really hoping the Democratic candidate will win at least one of the offices. Darren tells his friend Antonia, since the Democratic candidate for governor is supported by 53% of the voters and the Democratic candidate for attorney general is supported by 37% of the voters, that means 90% of the voters support the Democratic candidate for governor for attorney general. Antonia says, well, if that's true, then 101% of the voters support a Republican candidate for governor or attorney general. Is Darren's thinking correct? Why or why not? Well, I think obviously we would say no, it's not correct, right? He's getting this 90% by saying this 53% and this 37%. But look how many times he's counting these people. He's counting these people as this 53 and as this 37. So he should only count these people once. So is his thinking correct? Why or why not? I would say no, not correct. He's counting the DD people, right? The Democratic governor and the Democratic attorney general twice. Once as supporting the governor and again as the attorney general. So it says the union of two, by the way, the union we're going to find out, and this would be a good thing to put in our notes, is an or question. A union is or, it's one or the other. So it says A and B is the event consisting of all outcomes that are in either A or in B, or in both events. So what outcomes from the sample space are in the union of the events, the Democratic governor and Democratic attorney general? How can this be seen in your area model? So again, here it was the and, so it had to be one, it had to be both, right? So here we're going to say it's got to be a Democratic governor or a Democratic attorney general. So we'll say it's DR, RD, DD, OD, and DO, because remember it needs to have any Democrats at all. So I think that's what we're going to end up with here. So it says what outcomes from the sample space are in the union. Again, it's or. So you could like the Democratic governor and the Republican attorney general. You could like the Republican governor and the Democratic attorney general. You could like the Democrat for both. You could like the other governor and the Democratic attorney general. Or finally, you could like, getting a little confused here, the Democratic governor and the other. So you can see there's 5 things that could possibly be true here. These 5, 1, 2, 3, 4, 5. So it's way more people in both. And then what we can do here is we can figure out the odds of this happening. So what we'll do is we'll add these together, right? We'll say, all right, well, here there's 32.33%. Plus, here there's 14.8%. Here there's 19.61. Uh-oh. Here there's 2.59. And here there's 1.06. And if I add those together, you get 70.39%. So there's actually 70.39%. Oh, I want to put that here. 70.39% of one or the other, right? So there's a difference. 19.61% support both the Democrats. 70.39 support one or the other. And again, 19 supports this Democrat and this Democrat. 70% support this Democrat or this Democrat. So you can see unions are more inclusive, right? Or is more inclusive than and, right? If you have to do something and something else, that means you have to do 2 things. If you have to do something or something else, that means you only have to do one or the other. So it's easier to be in the union than it is in the intersection. So it says, what's the probability of the union of these two? I already answered that. We got 70.39%. It says, what's the probability that a randomly selected voter supports a Republican for governor and a Democrat? So now we're looking at an intersection question. So they have to have the Republican governor and the Democratic attorney general. So the Republican governor and the Democratic attorney general, we'll say it's 14.8%, right? Because it's an and question. What probability supports the Republican for governor or a Democrat attorney general? So now all of a sudden I'm going to change these colors, right? So you have to have, I already forgot, you have to have a probability selected supports the Republican for governor or a Democrat for attorney general. All right, so the Republican for governor or the Democrat attorney general, right? And is this 14.8% or means I'm going to add up all these people together. So I'm going to add up 24.4 plus 14.8 plus 0.8 plus 19.61 plus 2.59, and I get 62.2%. So I'll go down here and I will put in the 62.2%. All right, I'm going to pause and keep going here. Viola described the following method for calculating the probability in Part E of Problem 336. She said, I shaded all the outcomes for a voter preferring the Republican governor and all the outcomes for a voter preferring a Democratic attorney general. But I noticed that there were some outcomes that were shaded twice. So I just added the original probabilities and subtracted the probability of the overlapping outcomes. 0.4 plus 0.37 minus 14.8 equals 62.2. Does Viola's answer match your answer? So let's take a look at what she did. She went ahead and said, all right, well, let's see here. I know that 40% of the people support the Republican governor, right? And I know that 37% of the people support the Republican attorney general. So we have our left and our right crosses there. So she said, look, these people were getting counted twice, and I didn't want that. So I just counted all these 40% here. I counted all these 40%, and then I counted all these 37%, right? And that was 70%. And then I just subtracted the people that got counted twice so that I only counted them once. And we got that answer. So does Viola's answer match ours? Yeah, it does. Yes, it matches, right? And does Viola's method always work? Why or why not? Yeah, I mean, as long as you're doing it correctly, it should work. You just got to be mindful that, you know, of the questions they're asking and how they're answering the question. But there's definitely a way to do that. And so let me go ahead and pause this and get this out of the way. But that's just a nice little shortcut. But that's known as the addition rule. When you add up the entire probability and then add up another entire probability and subtract the part that happens twice, or the intersection, that's known as the addition rule. So if we go back to these notes, again, I just want to make this super clear, if I can, which I don't know if I can, but the intersection of two events is like an and question. It's got to be A and B. They both have to happen. The union of two events is an or question. It's where one thing happens or the other thing happens. And so, like I said, the union is usually more inclusive. It'll usually be a higher number than the intersection. The addition rule is that shortcut that she just said, where you add up the column and the row and subtract the overlap. You can add up those 5 columns over here one by one, right? In that example, she could have like gone, you know, added up the column and then added up the row one at a time, or just take the totals and subtract. So that, again, that's the addition rule. All right, so a popular restaurant in the mall has conducted marketing research on 4 new salads and considered putting on a menu. The percentages of study participants in the various age categories and their salad preferences are shown in the table below. Salad preference was found to be independent of age. That means that older people don't necessarily like one more than the other. So let's figure out how we're going to calculate this. So in order to get under 25, right, I'm just going to say, all right, well, 0.36, under 25%, 36% of the people like feta cheese. I'll multiply by 0.1, which is 0.36. I'll move the decimal twice, and I'm going to get 3.6% right here. So that's how I'm going to calculate that. I'm going to go ahead and pause right now and fill in the rest of this table. But again, hopefully we know 0.36 times 0.1 and then move the decimal. So it says people who participated in the study will be randomly selected for face-to-face interviews. What is the probability that the marketing department will randomly select someone who is 55 or older and prefers a chicken sandwich? So this 55 or older, these people are 55 or older, right? So let me change the colors here. These people are all 55 or older. And they prefer the barbecue chicken sandwich. So you got to have both slashes here because this is a intersection problem. It's an and question. So I'm just going to go ahead and add those up. I'm going to go ahead and I'm going to say 4.8 plus 3.6 plus 3. So I'm going to get 11.4% people meet both of those. So 11.4%. Actually, I'm going to have to get rid of all these checks first. There we go. So 11.4%. All right, now it says in the event that you analyzed in part A an intersection or a union, like we said, it was an intersection. So it was an intersection for sure. It was an and question. Don't let that or fool you. I wish they hadn't done that. 55 or older just means that there's more than 55-year-olds. It says, how does the intersection of 55 or older and barbecue different than the intersection of 55 or older and barbecue? So I think they misasked this question. Yeah, I think they miss. It says in the event you analyze part A in the intersection, how does the intersection of 55 or older and barbecue differ from the union of 55 or older? Well, it should say or barbecue right here, not and. So that's my first concern. This should say or. So the book's kind of going a little wonky on us right there. That should say or, not and. And the difference would be, again, if it was the or question. If it was or, we would want to count all of these people. I'll just do it with a line. If it was or, we'd want to count all of these people, all of these people, all of these people, and all of these people. So we would add them all up. So it says calculate the probability of 55 or older or barbecue using the addition rule. So the addition rule would basically say this, kind of a nice little shortcut, right? 60% of the people like 60% of the people like barbecue chicken, plus 8% of people are 55 to 64, plus 6% of people are 65 to 74, plus 5% of people are over 75, right? And then we'll just subtract. We already know that 11.4% of people, we already counted these people, are 11.4%. We'll subtract that 11.4%, and that will give us our answer. So it's going to be 60 plus 8. I don't want to do that. 60 plus 8 plus 6 plus 5 minus 11.4. We're going to get 67.6% of people are the or. Geez, 67.6% of people are the or the union. So it says, what's the probability that a randomly selected person from the study is under 75 years old? Well, here's two ways we could do this. We could add up all these. We could say 0.5 plus 3 plus 0.5 plus 1 is 5%. Or the next question asks us the complement. The complement says this. We can do the opposite. We could say this is 100% of the people, and 5%, I'm sorry, what's the probability the random selection person is under 75? I'm sorry, I read that wrong. So let me try that again. I'm going to redo that here. By the way, I got a bunch of crap on this, so let me get rid of this. So what percentage of the people are under 75 years old? It's 36 plus 14 is 46, 50, 67, 77, 81, 89, 95. So if I just add up 36, 14, 17, 14, 8, and 65, I get 95%. But it's also, question E isn't here, but question E says, is there another way to do it? Well, we could say, well, there's 100% of the people, 5% of them are older than 75, so the other 95% must be less, and that is known as the complement. Okay, the complement of an event is when you figure out the odds of it not happening and subtract. So it asks me, what are the odds that someone's over 75? I'm sorry, under 75. Well, I'll just figure out the odds of them being over 75, 5, and subtract it, and then I'll know what the odds are of the other. This has to add up to 95 because these people don't. I was clear as mud there. I apologize. Sometimes it's easier to figure out the probability that something will not happen than the probability that it will happen. When finding the probability that something will not happen, you're looking for the complement. That's what we just did, right? We figured out what the odds of them being over 75 were and then subtracted the opposite. So the complement is a set of all outcomes in the sample space that are not included in the event. Show two ways to solve the problem below, then decide which way you prefer and explain why. So the marketing department has interviewed people of all different age groups about barbecue chicken salad, but now they need information about why the other salads are less popular. So what is the probability that the next person randomly chooses will not prefer the barbecue chicken salad? Well, let's go ahead and look at that. Let me go to the answers here because I want to have this table and I deleted mine like an idiot. So it's like frozen real quick. Okay. So what it's saying is, it didn't make the table for me. Oh, this is a catastrophe. Okay, well, anyway, if I go here, it's frozen again. This is just a disaster. I apologize. I owe you like 30 seconds of your life back. Okay, so it's saying, what are the odds that someone would pick something other than a barbecue chicken salad? Well, if 60% of the people would choose a barbecue chicken salad, 100 minus 60 is 40. So 40% of the people would choose something else, right? And then if the probability of an event A is represented by the probability of A, how can you symbolically represent the probability of the complement? Well, we could say 1 minus P of A. And again, let me go here and show you what I mean. But we're just subtracting the probability of that event, right? So no big deal when this thing unfreezes. We can go back and say, whatever the probability is, we'll just say 1 minus the probability of that event, and we'll be done. So I'm sorry, I'm supposed to call my cousin right now, so I'm obviously distracted. Well, maybe not obviously, but that's why this video went south quickly. So I'm gonna sign off and we'll go from there.